So you can see that today we are skipping over a section. I just feel like for a block day, this is a better thing to do because we'll have more time to focus on it. So all of today we're going to talk about isosceles triangles. Everything today is talking about isosceles triangles. And if we draw an isosceles triangle, the two congruent sides are called the legs. Now remember, it doesn't have to be an acute isosceles triangle. It could also be an obtuse isosceles triangle. But the sides are still the legs. And that's going to be the two sides that connect around that angle. Then vertex angle is the angle where the two sides connect. So when the two legs come together, then that is the vertex angle. Same with obtuse triangle. If we look at that obtuse angle, that's the vertex angle. And those are the two legs. The base. The base is the side, like the odd man out, doesn't equal the other sides. And in the obtuse triangle, the base would be the longest side. In the acute triangle, probably the shortest side, but not necessarily. Base angles. Well, if this side down here is the base, the two angles that are down here connected to the base are the base angles. So basically, thank you, the base angles are the congruent angles.
That was so good.
Thank you.
You're so fun.
Okay, guys, she's a comedian.
All right, so we have some theorems. The base angles theorem. The base angles theorem says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if you put two tick marks in the picture, what you're basically putting in there are two little arrows that point to the congruent sides. So these two sides, look across from them, those two angles, those are congruent. And the converse of that is, if you know these two angles are congruent, look across from those two angles, and you'll find the two congruent sides. It's actually pretty handy. Corollary to the base angles theorem, so in other words a connection, this still works in an equilateral triangle. In an equilateral triangle, though, if all three sides are congruent, the three sides are pointing at the three angles, so it makes the three angles congruent. Plus, we said, if all three angles are congruent, we actually know how big they are, because 180 divided by 3 is 60. So in an equilateral triangle, all the angles are 60 degrees. The sides can be any length, though. Remember, they could be 29, 29, 29. They're just some measurement. Okay, let's practice a few of those, and then I think we'll be ready to work. All right, so this picture is a little complicated. We have to focus on just the sides they tell us. If segment JN here is congruent to segment NM here, then ignore those lines inside. We don't want to focus on KN or LN. They don't really exist now. We just have this triangle. If these two sides are congruent, which two angles do we now know are congruent? J and M. We're basically going to look across from the sides, and J and M will be congruent. So what if LM is congruent to LN? Now we're looking basically at this isosceles triangle. So M and N are the congruent angles. Now let's switch and look at the angles first. So if angle NKM KM, this angle, is congruent to NMK, this angle. Now we're focusing on this triangle. So which sides are across from those two congruent angles? Across from K is MN, and across from M is KN. So those are my two congruent sides. If angle LJN, this angle, is congruent to angle LNJ, this angle, now we're just focusing on that triangle, and across from angle J is LM, and across from angle N is LJ. So those are the two congruent sides. Okay, math. We can do some math with them too. The first thing we should notice, all three sides are congruent. So if all three sides are congruent, it is a what triangle? Equilateral. But now we know that an equilateral triangle is also equiangular. And in an equiangular triangle, all the angles are 60 degrees. So if 2x equals 60, then x equals 30. So we can match all of those things up. In the next triangle, the three angles are congruent, so it's equiangular. But if the three angles are congruent, the three sides are congruent. Since this side is 31, all the sides are 31, so there's x. So what if the pictures get a little trickier? Well, now we just have to start looking for different parts, label everything you can possibly think of, and somewhere along the line you'll find some stuff. So I notice there's a right angle down here. I know that's 90 degrees. Anything else you see in here? This one's equilateral. So not only are all three of these sides y minus 25, I don't know if I want to label that, but they're all y minus 25, but I also know something about the angles. If all three angles or sides are equal, then all the angles are 60. So that one,
And the rest of the 90 degrees is there.
exactly. So that 60 is only part of the 90, so then this part is 30. What kind of triangle is this over here? It's isosceles. We can see those two angles are congruent. That means these two sides are congruent. Oh, and look, I don't care if this same tick mark is in more than one triangle. If it's the same tick mark, it means it's the same thing. So if this tick mark says y minus 25 and it also says x, then they're equal to each other. Although that's not going to do us a lot of good right now. But angle y, maybe we can find that. Well, if we've got an isosceles triangle, 180 degrees, we can subtract out the vertex angle. That's always going to be the odd man out. We've got 150 degrees. That goes for both base angles then. Both base angles are going to be the same amount. So both base angles are 75 degrees. So that's y. So if y is 75, then y minus 25 is 50. And x was one of the congruent sides, so x is 50. All right, so eventually we found everything. In this one, this triangle's equilateral, this triangle's isosceles. Here's that vertex angle in an isosceles triangle again. So we could do 180 minus 40. That's 140. So if that's the vertex angle, then all we have to do is divide this by 2 to get the two base angles. So my two base angles are 70. And in this triangle, all the angles are 60. But now that we know that x is 70, we could plug that in. So 70 minus y should equal 2y plus 10. Those are the two sides. I know they're congruent. And then I can just solve for y. So let's add y to both sides. 70 equals 3y plus 10. Subtract 10. If 3y is 60, then y is 20. And that's all they wanted, was for us to find x and y. So y is 20. So those are just some examples of some things we might have to do.